Friends, very good morning. Today we are going to see some problems under double integration. Double integration under Cartesian coordinates is what we have discussing from our previous video. In previous videos we have discussed about problems under Cartesian coordinates with constant types. Okay, but today we are going to see the same kind of problems on the Cartesian coordinates but with variables. Okay, so today we are going to see double integration also the problems under Cartesian coordinates. Yes, Cartesian coordinates. Okay, then okay, fine, with variable limits. Okay, with variable limits. Okay, variable variable limits. Okay, so before going to the topic, you have to know one rule. Okay, so you are having two integrations and you are having a function of x and y. Okay, you are having this. Okay, so the rule is when the inner integral is of functions of x. Okay, you have to note it clearly, so please write it down. When f of x comma y is integrated and suppose the inner integral is having the limits as the functions of x, then first integration should be with respect to y and next integration should be with respect to x. Okay, if the function f of x comma y is integrated and the inner integral is having limits as the functions of y, then the first integration should be done with respect to x and then with respect to y. Okay, so you have to write it clearly in your own words. What I am telling is this function is about to be integrated. The limits of the inner integral is having some limits. The limits are functions of x, means you should integrate the inner integral with respect to y. Okay, and then entire integral with respect to x. So when the limits are the functions of y, so you have to integrate the first integral or the inner integral with respect to x and then later entire integral with respect to y. So this is the rule. You have to write the rule in words followed by these two notations. Okay, followed by these two representations. Okay, now in our previous examples on our previous video we have seen problems like 0 to b, 0 to a, or integral 0 to 1, integral a to b. Some arbitrary constants or variable constants will be there. Yes, okay, and where arbitrary constants 0 and 1 and 2 are numeric constants. Okay, but whatever it is, they are constant. We have seen the problems with constant limits. Okay, now we are going to see the problems under variable limits. Okay, so here you are having one more rule. One more rule is when you are having limits as constants and variables means, okay, limits as constant and variable means, okay, dx dy or dy dx means here the inner limit should be variable limit and external limit should be constant limit. Okay, you have to keep it in mind. For the limits, the existing two sets, one is variable set and one is constant set. Okay, so two pair of variable limits, a pair of variable limits and a pair of constant limits. Okay, I am telling as upper and the lower limit. Okay, means always the external limit should be constant and inner integration should have the variable limit. Okay, you have to keep it in mind. Okay, so following these two rules we are going to solve some problems. Okay, so my question here is, the inner limit is a variable. Okay, variable limit. Here you are having x. What kind of variables? Whether it is functions of y or functions of x, the variables will be of y. The variables may be of any functions of y, whether it is y or y square or root y, whatever it is. Okay, suppose if I am having y here, means the variable should be any functions of x. Okay, the variable should be any functions of x. Okay, so you have to keep these two rules in your mind. Okay, now one more thing is, many of you can have doubt, is it not possible to integrate f of x comma y if I am having x first, and if I am having 0 to x square, that is a functions of x, dy, a constant limit 0 to 1 or something. Okay, let me take it as x into x plus y. Okay, it will be x plus y. So if I am having the function like this, I do not mention that it is not possible to integrate it with respect to x first and substituting this x square for that x and later for y. It is not, I am not mentioning like that, but depending on the rule, this is not the prescribed form. Of solving double integration. Okay, it is quite possible. See, x square plus xy, and later I can substitute limits for x. Later I have substitute limits for x. So, and I have to integrate with respect to y. So here you are having functions of x and y and integrate with respect to x and y. Here also you will have, okay, here also x plus y means on integrating x you will get x square by 2 and xy, so x square by 2 plus xy, so 0 to x square is here, so you will get x square the whole square by 2 plus x square y, and then you have to integrate with respect to y. Again you will get x power 4y by 2 plus x power x2 into y square by 2, and you have to substitute limits for y 0 to 1. So limits will be substituted only for y, so these x powers will remain like that. X power 4 by 2 plus x square, and these terms will not change. Sometimes you may have the constants along with y, 1, and here also 1. So 1 by 2 and 1 will be here. So there is no use of maintaining the same variables again and again. Okay, so that is why it is not prescribed. Okay, so I never mentioned that it is not possible, but don't use these things in examinations. Okay, this is not prescribed. That is why I am mentioning these two forms as correct form. Okay, these two forms as the correct form. Okay, you have to keep these things in mind. Okay, so we are going to see the first example. Our example is evaluate integral 0 to 5 integral 0 to x square x into x square plus y square dx dy. Okay, so solution, let me take it as I 0 to 5 integral 0 to x square. So I am multiplying the x with x square plus y square, so I will get x cube plus x y square and then dx dy. Okay, this is what is given. Okay, this is given, and this can be, okay, this is given, and now I am going to change it into the correct form. So before that I separate this with the brackets, integral 0 to x square into x cube plus xy square into dy, okay, and then dx, because here the limits are correct, because external limits are constant and inner limits are variables, okay, but the inner interval is having the function of x as its limit, okay, but it is integrated with respect to x again, so it is wrong. You have to interchange the limits, sorry, you have to interchange the order of integration. So now it is in correct form. So here you will get integral 0 to 5 x cube y plus x y cube by 3, xy cube by 3 into dx, okay, that is equal to integral 0 to 5 x, okay, okay, cube, instead of y we have to substitute the limits, okay, the limits are 0 to x square, okay, limits are 0 to x square, okay, so x cube into x square plus x into x square the whole power 3 by 3 into dx, so we know that a power m into a power n equal to a power m plus n, and also a power m the whole power n equal to a power mn, okay. So by these two rules you will get integral 0 to 5 x power 3 into x power 2 will become x power 3 plus 2, so it is x power 5 plus x into x power 2 whole power 3 will become x power 6, okay, by 3, okay, into dx, okay, then you will get integral 0 to 5 x power 6, sorry, it is x power 5 plus x power 7 by 3, because when x is the base means the power is nothing, means the power is 1, so x power 1, so x power 1 into x power 6 will be x power 1 plus 6, that is x power 7 by 3 into dx. Now you have to integrate this with respect to x, okay. So you will get x power 6 by 6 plus x power 8 by 8 into 3, okay, 8 into 3, 0 to 5, okay, 8 into 3, that is equal to integral, so that is equal to x power 6 by 6 plus x power 8 by 24, 0 to 5, so you have to substitute the limit, you will get 5 power 6 by 6 plus 5 power 6, sorry, it is 5 power 8, 5 power 8 by 24. So out of 5 power 6 and 5 power 8 you will have 5 power 6 as common, and also the LCM of 6 and 24 is 24, okay, LCM of 6 and 24 is 24, so you have to multiply this 1 by 6 into 4 by 4, so out of 5 power 8 5 power 6 went out, means you will have 5 square by 24, okay, so that is equal to 4 plus 5 square is 25. Outside you are having 5 power 6 divided by 6 fours are 24 and another denominator is also 24, so that is equal to 5 power 6 into 29 by 24. Okay, so this is our solution. I hope you all understand this problem. Okay, so we are going to see one more problem. So please okay, just a minute. Okay, second problem. The second problem is evaluate integral 0 to a and integral 0 to root of a square minus x square then dx dy. Okay, so solution. So they have given 0 to a, I equal to integral 0 to a, I equal to integral 0 to a, then integral 0 to root of a square minus x square dx dy. So it is not in the correct form, but the limits are right. The external limits are constant, inner limits are functions. So since it is functions of x, you have to interchange the limit so that the limits as functions of x, the first integration with respect to y, so it should be changed to integral 0 to a, integral 0 to root of a square minus x square dx dy cannot be, it can be dy and dx. On integrating y you will get, y, so limits are root of a square minus x square then 0 then dx then integral 0 to a. Okay, so that is equal to integral 0 to a, then you will get root of a square minus x square minus 0 into dx. Okay, that is equal to integral 0 to a root of a square minus x square dx. So for integration of root of a square minus x square dx, you are having the formula x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a, this is the formula. The limits are 0 to a. So this is the formula for this integral root of a square minus x square dx will have the formula x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. So after substituting the limit you will get a by 2, okay, root of a square minus a square plus a square by 2 sine inverse of a by a minus 0 by 2 root of a square minus 0 square plus a square by 2 sine inverse of 0 by a. Okay, so this is one set of operation, this is another set of operation. Okay, here a by 2 into a square minus a square will become 0 plus a square by 2 sine inverse of a by a is 1 minus 0 by 2 means everything will become 0. So 0 into a square plus a square by 2 into sine inverse of 0. So that is equal to, okay, that is equal to a that is equal to a square by 2 sine inverse of 1 minus a square by 2, okay, a square by 2 sine inverse of 0. Okay, so it is a square by 2 sine inverse of 1 is pi by 2 minus a square by 2 into sine inverse of 0 is 0, that is equal to a square by 2 into pi by 2, that is equal to pi a square by 4. Okay, this is the solution. Okay, is the required solution. Okay, so let us see one more problem. Let us see one more problem under this. Okay, because these are very important. Okay, so let us discuss one more problem also. So this is our third problem. This is our third problem. The problem here is evaluate integral 0 to 1, then integral 0 to root of 1 plus x square, then dx dy divided by 1 plus x square plus y square. So this is the problem given. So this is very important problem. Okay, this is very important problem. Actually I thought of giving this problem as homework, but since this is very important and it is having a little more complexity than the previous problems, I would like to solve it for your understanding. Okay, so solution, they have given I equal to 0 to 1 integral 0 to root of 1 plus x square. The limits are right. The inner limit is of variable and external limit is of constants. Okay, so no problem, limits are correct, but the inner limit is a function of x. So you should have dy first. Okay, so you should have dy first and then dx. Okay, this is the correct form. Okay, this is given, so you have to write separately, and this is the correct form. Okay, this is correct form. Okay, now integral 0 to 1 integral root 0 to root of 1 plus x square, then you are having dy. Okay, dy divided by 1 plus x square plus y square and then dx. So this is what we will get. So here I should have only two things, because all our functions for sine inverse, cos inverse, tan, whatever it is, you will have one constant and one variables. For example, if I am having, in the previous problem we have seen one formula, no, 1 divided by what, that is for sine inverse of x by a. See what we are having, one variable and one constant. Okay, integral root of a minus x square means you will have x by 2 root of a minus x square plus a square by 2 sine inverse of x by a. Okay, do you understand? Okay, so before that also we have seen another problem. In this problem there are no trigonometric terms. Dear students, you may have a doubt here, why didn't you substitute the lower limit? Because lower limit will become 0. On substituting, the entire lower limit will become 0. Okay, so that is why we have not substituted the lower limit, because on substituting 0 for y, it will become x cube into 0 plus x into 0 cube by 3. So these two terms will become 0. The sum of two zeros is also 0. That is why we have not integrated it with respect to y and substituted 0. Okay. So here we have avoided, but here I have mentioned it for your reference. Okay. So here what I'm coming to say is on any in trigonometric terms, okay, on any trigonometric functions in integrations, if you want to have some formula form trigonometry, means you should have one constant and one variable. There should not be two constants or there should not be two variables. Here you are having two variables, x square and y square. So you should treat one of the variable as constant. You should treat one of the variable as the constant. Okay. So since I am going to integrate with respect to y, I am treating y as the variable and x as the constant. I am treating x as the constant. So I am going to rewrite this as integer 0 to 1 integer 0 to root of 1 plus x square. Okay, 1 plus x square. How I am going to write is dy divided by this 1 plus x square as the square. Since it is square, no, since it is y square. See, something plus y square dy is there. So I have to write this as square. But here I am having 1 plus x square. So I am writing it as 1 plus x square. Okay, 1 plus x square. What is this 1 plus x square? Square root. Okay, square root of 1 plus x square the whole square. So this square root and square will get cancelled. I will get the same value. So I have substituted, I have obtained the value of this circle. Okay, so square root of 1 plus x square plus y square into dx. So now entirely this is constant and entirely this is y square. So this is our dy by a square plus y square. This is my dy by a square plus y square. So if I am having integral dy by a square plus y square, means I will have the formula 1 by a tan inverse of y by a. Okay, when I am having integral dy by a square plus y square, means I will have 1 by a tan inverse of y by a. So obviously we will get the result integral 0 to 1, then this will become 1 by a. What is a? This is a square, no? So 1 by a means root of 1 plus x square. So 1 by a tan inverse of y by a. So y is y. So tan inverse of, you will have y. So what is our y? Y is again y divided by a. What is our a? Root of 1 plus x square. So into 0 to 1, 1 by a tan inverse of y by a into dx. So for this you have to substitute the limit. 0 to root of 1 plus x square. 0 to root of 1 plus x square. So substitute the value for y. So you will get integral 0 to 1 divided by root of 1 plus x square tan inverse of square root of 1 plus x square divided by root of 1 plus x square, then minus 1 by root of 1 plus x square tan inverse of 0 by root of 1 plus x square into dx. Okay. 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 Now this can be simplified as 1 by root of 1 plus x square, 1 by root of 1 plus x square tan inverse of 1 minus 1 by root of 1 plus x square, okay, tan inverse of 0, tan inverse of 0 into dx. Okay, tan inverse of 0 into dx. So in tan, when will you get 0? See, I am writing here sine, cos, tan, 0 degree, 10 degree, okay, 45 degree, 60 degree, then 90 degree. So 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So again 1, root 3 by 2, 1 by 2, then sorry, it is 0, root 3 by 2, 1 by root 2, then 1 by 2, then 0. Okay, 0 by 1, 0 divided by thing is 0 and 1 divided by 0 is indeterminate, infinity. Okay, anything divided by 0 will give infinity. Then it is 1 by root 3, then 1, then root 3, then infinity. Okay, so here you are having tan inverse of 0 means where you are getting 0, for tan 0 you are getting 0, so it is 0, so minus 0. Tan inverse of 1 means where you are getting 1, for 45 degree. Okay, 45 degree means pi by 4, pi means 180. Okay, pi by 2 is 90, pi by 4 is 45 degree. Okay, okay, then it is 1 by root of 1 plus x square into pi by 4, okay, minus 0, integral 0 to 1 into dx, okay. Now here you will get integral 0 to 1. Okay, here you will get pi by 4, pi by 4 into 0 to 1 dx divided by root of 1 plus x square, dx divided by root of 1 plus x square. Okay, so let me write it. I write it clearly. Here you are getting pi by 4 integral 0 to 1 dx divided by root of 1 plus x square. Okay, so if I am having something like this, here also we are having some formula. The formula is pi by 4 into, the formula is log of x plus, okay, log of x plus root of 1 plus x square, log of x plus root of 1 plus x square. The limits are 0 to 1, the limits are 0 to 1. Okay, so substitute that. You will get you will get pi by 4 into log of 1 plus square root of 1 plus 1 minus log of 0 plus square root of 1 plus 0. Then you will get pi by 4 into log of 1 plus root 2 minus log of 0 plus root 1, that is equal to log 1. So we know that log 1 equal to 0. So we will have the result as pi by 4 into log of 1 plus root 2 minus 0, that is equal to pi by 4 log of 1 plus root 2. Pi by 4 log of 1 plus root 2. This is our result. So now I am going to give some homework. Okay, I am going to give some homework. So the first problem in homework is evaluate integral 0 to 1, integral 0 to 1 minus x, y, dy, dx. When it is in correct form, you have to do as it is. Okay, dy dx. Answer is, okay, answer is 1 by 6. Okay. Second problem is integral 0 to 1, integral x to root x, then xy into x plus y dx dy. Answer, okay, answer is 3 by 56. Answer is 3 by 56. And then the last problem, the third problem. So the third problem is integral 0 to 4, then integral 0 to x square, then e power y by x dy dx. Okay, so here this problem you will have the answer. For this you are having the answer 3 e power 4 minus 7. This is your answer. Okay, you have to try these problems. Okay, I think you may feel little difficult when you try to solve the third problem. Okay, so you please do first two problems as homework. Let me solve this third homework. Okay, solution. Here I equal to integral 0 to 4, integral 0 to x square. So here I am having e power y by x, and the limits are functions of x, the inner limits are functions of x, and first integral is with respect to y, means it is correct, and then dx, so it is correct. So now I am having integral 0 to 4 e power y by x, means what is constant? X is constant and y should be treated as variable. So e power x, on integrating e power x, I will get, see, integral of e power ax dx equal to e power ax by a. Okay, so in the same way here 1 by x is constant, so I will get e power y by x divided by 1 by x. Okay, 1 by x, but for y only we have to substitute, so x square and 0, then dx. Okay, so here we will have inter 0 to 4. So this 1 by x will let 1 by x be here itself. So here we will have e power of x square by x will become e power x. So e power x square by x minus e power 0 by x whole divided by 1 by x into dx. Okay, 1 by x into dx, that is equal to integral 0 to 4 e power x minus e power 0 by x. 0 by anything will become 0. So e power 0 divided by 1 by x dx, that is equal to integral 0 to 4 e power x minus 1 divided by 1 by x dx. Okay, e power x minus 1 into 1 by x dx. Now I am taking this denominator to the numerator, so I will get integral 0 to 4 x. The denominator is 1 by x, 1 by x. When it goes to the numerator, it will become x. So x into e power x minus 1 into dx. Okay, so it will become integral 0 to 4 x e power x then minus x dx. So for the first part, so here it can be separated into two types, or it can be separated into two parts, or it can be solved as it is. So for easiness, I am going to split it as equal to integral 0 to 4 x e power x dx minus integral 0 to 4 x dx. Okay, so here I am having x e power x. You know that there is a 5 set of functions, and depending upon the 5 types, we have to choose u from those 5 functions. So the order of priority is based on those 5 functions. So I, L, A, T, E. So inverse, logarithmic, algebraic, trigonometric, exponential. Okay, inverse, logarithmic, algebraic, trigonometry, and exponential. Exponential should be given last priority, so it should not be taken as u. It is not possible to take it as u since it is having the least priority. But algebraic function is having the most priority when compared to exponential function, so it can be chosen as u. So in Bernoulli's formula, there is a formula called Bernoulli's formula. Integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus u 4 v4 minus etc. It is something like this. Okay, so when we can solve this integration, when the derivatives of u completely vanish, that is when the derivative of u completely becomes 0, we can stop. Okay, so I'm writing here x is called u, e power x dx is called dv. Okay, so u and dv. What is u? U equal to x, dv equal to e power x dx. Then what is v? V equal to integral dv, that is equal to integral e power x dx, that is also e power x, that is also e power x. Okay, therefore v equal to e power x. Okay, sometimes you will have some other function, you have to take the entire function as dv, then you have to integrate that. After that only you can find e power x. You do not simply take u is x, v is e power x. You should not take like that. Entire thing should be taken as dv and it should be integrated to find v, and after finding v only you have to proceed further. So u equal to x, v equal to e power x. Okay, then u dash equal to 1 and v1 means integral of v. Okay, integral of v, so e power x dx, that is equal to e power x. U double dash is differentiation of this, that is 0. v2 means again integration of this, inter e power x dx, that is equal to e power x dx, that is equal to e power x. So the formula is uv minus u dash v1. Okay, so sorry, it is uv minus u dash v1 plus u double dash uv minus uv minus u dash v1 plus u double dash v2 and so on. Okay, so you will get x, okay, e power x minus 1 into e power x, 1 e power x, then the last u double dash v2 is not necessary to write since it becomes 0. So uv minus u dash v1. So limits are 0 to a minus x dx will become x square by 2, x square by 2, so it is 0 to 4. So you will get a e power a minus, so it is 4, sorry, it is 4, my writing yes, it is 4. Yes, it is 4. So 0 to 4, and here also it is 0 to 4. Okay, it is not, it is 0 to 4. Then you will get 4 e power 4 minus 1 into e power 4, then minus 0 minus e power 0, 0 e power 0 minus 1 into e power 0. Okay, and after that minus 4 square by 2 minus 0 square by 2, that is equal to 3 e power 4 minus e power 0, 0 e power 0 is 0, then minus of minus is plus 1, then minus 4 square is 16, 16 by 2, 16 by 2 is 8, 1 minus 8, minus of minus, it will become plus 0, that is equal to 3 e power 4, 1 minus 8 is minus 7. So this is our solution, okay. So dear students, I hope you all understood the problems under Cartesian coordinates. So go through these problems very carefully and clearly, get concept clearly understood. Okay, so after that only you will be able to switch on to the next stage of double integration. So next stage we are going to see the double integration under polar coordinates. Okay, where you will have r and theta. Okay, so after that you have to know how to find the area, okay, of the plane curve under Cartesian polar coordinates. So you have to very clear with the fundamentals. Okay, so thank you all for watching this video. Thank you all once again.